In the electron configuration of osmium, atomic number 76, the designation of the orbital with the highest energy is... Alright, so we're talking about the electron configuration. And apparently, the straight out way to solve this problem is to write the electron configuration of osmium, which is, well, not very hard to do. If you look at osmium is number 76, and to write its electron configuration, you look back on the last noble gas element before it. So osmium, the last noble gas element before it is xenon. And after xenon, we go on to the 6th row of the periodic table, and that's 6s2, and after 6s it's the first f orbital, f14. Osmium is actually in the transition metal area, the D area, and 6 columns right below iron, 5d6. So after you write the electron configuration, you realize that the orbital with the highest energy, the one that's filled up the last, is 5d. But you're going to need to write the electron configuration. And to do that, you're going to be looking at your periodic table, and, well, if we're talking about just the orbital with the highest energy, there is actually an easier way. Now you look at osmium. We know the electron configuration, in the electron configuration, the last orbital is the one with the highest energy. And the last orbital also determines the position of your element on the periodic table. This is the periodic table. Anything here in these two columns, well, would end up with s orbital, and anything here would end up with p orbital, which means their highest energy orbital would be a p orbital. Anything here would be ended with a d orbital, and anything here would be ended in an f orbital. And osmium, if you look at the periodic table, is right about here. And that means the designation of the orbital with the highest energy is definitely D. Otherwise it wouldn't be in the area. Alright, what about a number? Which D? 3, 4, 5? Well, that depends on which row in the D area is osmium. The area has 4 rows. Now, didn't start with 1. It can't. Okay, so where do we have our first D orbital? That's right, 3D. And so on and so forth. So which row is osmium? The 3rd row in the D area. 3D, 4D, 5D. In this way, you don't really need to do any electron configuration. All you need to do is look and count up to 4, 5, 6. Pretty easy to do, right?